The last method of customer integration is the conjoint analysis. Conjoint analysis has been around for a while, and it has been developed because we recognized actually that, well, people don't buy specific features of a product. They don't buy the speed of a car. They don't buy the full consumption of a car. They don't buy a specific interior design of the car. They buy a car, meaning a set of features. So as an innovation manager, you actually want to know what would be the perfect set of features that could be put on my platform that will create the most value for the customer. So the conjoint analysis recognizes that in real life, customers make trade-off decisions. Yeah. So we know that, for instance, the speed of a car and the fuel consumption, well, these things are somehow interrelated. Yeah. If it's driving faster, the car will probably also require more fuel. So therefore, it would be good to know which of these two criteria are more important for the customer. So do they trade in fuel consumption for speed or the other way around? Then there are some characteristics that are quite difficult to capture, such as the brand. How important is the brand for the customer? When selecting a product. And the conjoint analysis is also able to calculate what is the specific contribution to the perceived benefit of a product of difficult to capture characteristics such as the brand. So the conjoint analysis is basically a statistical method, and in particular it uses non-metric analysis of variance to decompose the value of certain features and give a particular importance score for each of these features. So it helps us to design the perfect product. It captures the contribution of separate features to the overall value that the customer perceives from the product. You will see in a minute what this is all about. Just as a note, it is a method that is around for a while, and there are different variations of this method, and it's a really great tool to make product decisions. I don't go through step by step with you, but you have it in your materials how you proceed with the traditional conjoint analysis, but you will see in the example how it works. So let's say you are a manufacturer of a laptop, and there are basically 4 features that you can design: the CPU, the storage, the display, price. And for the CPU, you can do for 3 different attributes, so 3 different feature variants: 2.4, 2.6, and 2.8 gigahertz. For your hard drive storage space, you have 20, 30, and 40 gigabyte that you could do. For your display, you have 13, 15, and 17 inches. And then you have the price, 3 different price point: 1,500, 1,750, and 2,000 US dollar. So what would be, if you ask a customer separately each of these features, the perfect set be? Well, the faster the better. So every customer should, if he or she is sane, say, well, it should be 2.8 gigahertz and should have 40 gigabyte of storage space. With respect to the display, it's a little bit, it's not so obvious. So some might say the bigger the better, others say the smaller the better, the portability. So here we don't really know what the customer would say. And with respect to the price, I think we can agree that everybody would say, well, 1,500, that's the best price, right? So if we would let a customer rate these 4 features, we will probably end up with a pretty expensive product to produce that we have to sell at a very low price. So as a marketer, I would, of course, and you, of course, as well, ask, well, what is it that the additional increase from 2.6 to 2.8 gigahertz creates in additional value? Does this really make a difference for the customer? And the second question is, what is more important for the customer? The price, the CPU, the display? What is the feature that actually is most important for the customer? And to answer these two questions, you do a conjoint analysis. In the first step, you build combinations of these features and attributes that represent full products. This looks like that. So you have the first laptop with a specific combination, in that case 2.6 gigahertz CPU, 20 gigabyte of storage space, a 13.1 inches display at a price point of 1750. And then you have a laptop 2 with a different set of features and attributes, and the laptop 3 with, again, a different set. And that's exactly how we as customers, when we go into the stores, make our decision. We are presented with 3 specific feature sets or 3 different kinds of laptops, and then we have to pick one. And this is exactly what you also do in conjoint analysis. So based on an orthogonal design, you have 8, 10, 15 different product variations, and you as a customer have to bring them then into an order to say, oh, I like laptop number 2 best, laptop number 1 second best, laptop number 3 third best, and so on and so forth. And this order is the data points that enter the conjoint analysis. Drawing on these individual data points, so the rank order that you as a customer gave to laptop number 1, 2, and 3, based on these data points, conjoint analysis applies its algorithms and decomposes the value that each of these features and its attributes create and delivers a result that looks like that. So the CPU feature, for instance, you can see that the 2.4 gigahertz attribute creates a utility of 0.3, which increases by 2.2 points in utility when moving from 2.4 gigahertz to 2.6 gigahertz. So there's an additional utility the customer have that is quite substantial when moving up the ladder in terms of the gigahertz. And the additional value created when moving from 2.6 gigahertz to 2.8 gigahertz is even more. You can see the difference in utility moving from 0.5 to 0.8 is much, much higher. So obviously the 2.8 gigahertz attribute is the one that creates the most benefit for the customer. When it comes to the hard disk storage space, the picture looks a little bit different. You can see that the 20 gigabyte attribute is really barely creating any kind of benefit. The utility is by 0.1. 30 gigabyte in contrast has a utility of 0.6. So actually the additional value created by this 10 gigabyte more is substantial. But when going from 30 to 40 gigabyte, actually you can see the utility just increases slightly from 0.6 to 0.7. So for you as a marketer, you will actually see, okay, 20 gigabyte is definitely not enough. But the additional value created from going from 30 to 40 gigabyte, which increases my costs substantially, but the benefit and utility increase is rather slightly. So I would rather go for the 30 gigabyte because this creates enough utility and does not create that much costs as opposed to 40 gigabyte for me in the production. For the price, you can see, of course, the higher the price, the less utility is created by the product. But you can see that obviously the price elasticity is a little bit, or you have a critical price point. So when you go from 1.7 1,000 euros to 2,000 euros, you actually see you will not sell that product anymore. 2,000 is much too much, and you have to probably stick with the 1.7 thousand euros because nobody will buy the product at 2K anymore. And also for the display size, where we before said we were not really sure what kind of display size is the optimum, and you can see similar to the hardware storage that an additional increase in your display size from 15 to 17 does not really create a lot of additional value. So actually maybe better stick with the 15. And 13 inches is actually something that does not really create any kind of value. So better not go for this very small display size. So this kind of utility analysis, as you can see right there, is much more specific in the additional value created by these different attributes of the features, as opposed to asking customers, what do you want feature by feature? Because remember, customers are making these trade-off decisions when selecting between these three different laptop variations we had listed before. They are evaluating specific concepts, feature sets, and the conjoint analysis decomposes this into these separate utility values based on its algorithm. It's hidden. Yeah. On the right side, you see another table that actually also shows something that is referred to as the relative importance, which tells us if the feature, or what is the relevance of the feature for the entire purchasing decision. And you can see the CPU has an importance of 20%, the storage of 24%, the price of 36%, meaning that from all of these features, the price seems to be the one that is driving the selection of the product most. So in other terms, the feature price is actually the most important in that market, followed by the storage space of the hard drive, and then after that the CPU and the display size. How do we come to this? It's basically the span of the minimum and the maximum utility value created within the attributes of each feature. So for the price, you have a range from 0.1 to 1. So 0.1 for 2,000 euro and 1 for 1,500 euro. And so you have a total span of 0.9. And if you do this same exercise for all the features, you come up with these spans of minimum and maximum utility created of 0.5 for the CPU, of 0.6 for the storage, of 0.5 for the display, and again, just as illustrated before, 0.9 for the price. And if you make the sum out of them, 0.5 plus 0.6 plus 0.5 plus 0.9, you actually end up with 2.5. And then you see what is the relative importance of this 0.5 of the CPU compared to the sum of all spans of 2.5, and then you end up with 20%. Yeah. So in simple terms, the bigger the span within a feature and its attributes in the utility, the higher the importance naturally gets. Yeah. And this overview also allows you in the next step to calculate the benefit that a product set, feature set will create, even if this is a feature set that the customer hasn't even seen. You are knowing now the utility of each and every possible combination, and you can quickly calculate what the benefit is, even if you haven't built a prototype for that and presented it to a customer. So this is represented here. You see the CPU with, for each of these laptops, you see for the CPU, the storage, the display, and so on and so forth, what kind of utility is created by each of these features and the specific attribute that is selected for the laptop number 1, but also for laptop number 2, but also for laptop number 3. And by summing up the partial utilities of each of these attributes, you end up with a total utility score. And you can do this for all possible combination that you can imagine, and then select the one product variation that actually creates the highest value. So this is a great tool to decompose let's say, partial utility of each feature that the customer sees in the product by drawing on data that is very realistic, because customers are making trade-off decisions. They are not presented a set of features. They are not presented features. They are presented a product, which is a set of features. And the conjoint analysis is thereby very realistic to the real purchasing decision, and at the same time provides us with the utility values for each and every combination of features that we can possibly imagine in the back end. So this is a really good and great tool, common in market research for 20-25 years already, even longer, and can just strongly recommend to do this kind of method if you're trying to find out what is the perfect feature set you should launch on the market. So the advantage is clearly that it is a systematic evaluation of the customer benefit or utility, and it's an indirect evaluation. Just think about the price. For instance, we are not asking what is the perfect price for you. We are asking for a specific product with a feature and if people would choose it or not. So it is an indirect measurement of the willingness to pay, and we clearly can identify what is the additional utility created when going from one price point to the next. Then we have a description of the target customer by additional demographic information. So if we do not only ask people to rate these kind of products and bring them into a rank order, but also ask them things about their income and household size and age and so on and so forth, we might even classify and segment the market and say, oh, there is a segment of customers that are, for instance, not so price sensitive, and they are characterized by a higher income level, living in an urban environment. So you can enrich your conjoint analysis results by running a segmentation and profiling each of these segments so that you clearly know who these people are. And the final and I think most important advantage is that you collect data through a very realistic decision process that recognizes that customers and we all have to do trade-off decisions all the time when we are making our purchasing decision. The disadvantage is, well, okay, it's consuming time and costs, I know, but this applies to each and every method. The more problematic thing is that for radical innovations, this basically does not really work because people don't know what these products are and what these feature sets are. So actually only apply this method when you have to do with incremental and next generation product development issues. The methodological limitation with respect of the amount of features and attributes, that's something I did miss before. So actually the conjoint analysis really just works great if you have up to 5 to 7 features and 3 to 5 different attributes for each feature, because otherwise you will not be able to reduce the number of combination of products that you need to feed the model to a number that people can comprehend. So if you would require the customer to rank 20 or 40 different product variations from I like this one most and this one least, then actually every customer would be overwhelmed. So you are limited to a couple of features and attributes, but actually you can focus on those that are most important for you from a cost perspective, but also from the customer benefit that you expect that they deliver. So the conjoint analysis is fantastic for the later stage of development when you have to decide what is the specific feature set that could come on board, and also for testing and validation to find out what is the perfect product variation that you should then implement in your final product or product portfolio. And you can use more or less Joe and Jane average customers. I would say passive contributors are the best for that, because they can think in alternative and they have extensive user experience that is required to actually make a good choice between products. If they don't know anything about the products, then these respondents are not the optimal choice. And that could be the case with those customers with basic commitment, because you remember, as we classified them, extensive experience in using the product is not mandatory for them, because we mainly just want to know about the problems and needs they have, and not to test certain product variations that they should give us feedback for. So the passive contribution people are the best for that. Don't go for conjoint analysis with leading edge customers and all these frontiers, because it is too simplifying for them. And with the conjoint analysis, you actually want to find out what are the different features, utilities, and relevances for the entire market. So not these atypical users, but for the mass market. So therefore, the conjoint analysis is best performed with people that are these passive contributors. To see a specific example how that works and how you can use this thing to actually make educated marketing decisions, you have this article from Page and Rosenbaum from the late 80s. So the time where conjoint analysis starting to enter the business world, and it shows in great detail how the product line decisions were made using conjoint analysis in the area of kitchen appliances. So I think it's a mixer, if I remember correctly, and how to design this product portfolio of mixers to actually maximize profits and market shares. It's a great read, a classic.